Hi, my name is Meadow Ging-Wargo. I've been making long terms ever since I was in kindergarten. This one I have is from whenever I was in second grade. It's my favorite, and it is about pine cones. Now, when you think of pine cones, you may think of coming off of pine trees. They'll be really tiny, but the ones I'm talking about are big. They're from sequoia trees in Sequoia National Park in Kings Canyon, and I decided I wanted to do a project on them. My prediction is the longer the pine cone is, the more layers it would have. And for whenever I say layers, you may not know what I'm talking about. These lines are layers, and that's what I'm counting. And I thought because a pine cone is longer, there must be something filling in the gaps, as it seems to form. So the materials I used was a few pine cones, a tape measure, a pen, and a notebook. So the procedure I did was I collected pine cones, and whenever I collected them, I didn't go, oh, that one looks biggest, that one looks smallest, that one looks the right size, random. I just go, the ones that are in front of me, and I collect 4 of them at a time, because these are big, and I can't carry them all at once. And I brought them back to a picnic table at my campsite to measure them. Next I wrote the length and the layers, and I measured the pine cone from the stem, which is the bottom, right here, all the way to the top, up here. And I counted straight up, which means I did not go side to side like that. I went like up. And this is a better model. I don't go right there, then right there, and right there. It goes back and forth. I would go up straight, all the way to the top. And then I wrote the values down in the notebook. This is a picture from when I was in second grade in summer. We took a trip to Sequoia and Kings Canyon out in California. And I'm in the middle of a presentation that somebody's presenting right then, and I found all these pine cones because there's a lot of them laying around. And this one looked really big, so I decided to measure this one. So last I put the pine cones back where I found them because it's a national park. I can't keep the things. And then I walked them back in a bag because I can't carry 4 in my hands. And then I wore gloves the entire time because these are sappy and fresh. And this is my data table, and these are numbers I put on the computer because it's neater. And what I mean neater, I was in second grade when I wrote these down on a piece of paper. I originally wrote them all down on a piece of paper, and then I transferred that into the presentation because at first I didn't even know I was doing a project. I just thought, these are cool pine cones. I've never seen anything like this before. I want to measure them. So this is my table. That's the pine cone, that's the length, and that's the layers. And this is my graph, and they're kind of in the same spot. They're in this circle. They're not all the way over there and down there. But there's a couple that are scattered out, and it kind of has a line that goes straight up, and it shows that the more layers the longer it is, the more layers it has. So the graph shows that the length of the pine cone gets bigger if there is more layers. So in the graph, the pattern is not a perfect line. There's a couple scattered out, but it does seem to go up. For the more layered it has, it'll be longer. And I think if I found a new pine cone without measuring it, well, without counting the layers, I think if I just got a guess, I could round them to a certain amount of layers because they're all kind of the same. Like if you got a pine cone that was 6 inches and then 10 layers, it would probably be around that again. Any questions?